I hope you all are good and doing well for the preparation of your O-level exams. Guys, today the topic what we are going to discuss today is about a sequence pattern for O-levels. Here, first, before we start, I would like to tell you about the basic definition of sequence. Sequence is what it means. A sequence is basically a set of numbers, or you can say a pattern. It can be number and can be a pattern of numbers that follows a particular order, right? And each number in a sequence is called a term, and terms that follow each other in a sequence are called consecutive terms, right? For example, we can have different examples like for example, if we have a sequence of or pattern of numbers like 2, 6, 10, 14, and we have to write the next 2 or 3 terms, right, with the same pattern. Or if we have, say, uh, 92, 84, 76, and 68, and so on. So what to do? And okay, here you can see a specific pattern. What is the pattern which leads towards the successive terms or consecutive terms? We can see here the difference of the second term and first term is 4. Yani in the first term, if you add plus 4, you get 6, and then plus 4, you get 10, then plus 4, you have 14. It means this is a common pattern that for the very first term, this we call the first term. Here, these are the first terms. You have to add 4 to get the next term, and then 4 to the next term, and so on. So the next two term will be, by adding 4, we'll get 18, and then by adding 4 we get 22, and so on, right? This is a pattern. Each successive term can be obtained by adding 4 in the previous term. Same, you can see here, the numbers seem to be decreasing. Here I can say this is from 92 to 84. What is the difference? It will be minus 8, and then again 76 to 84 is minus 8 again, and minus 8 again. So this is another pattern that each time you need to minus 8 from the current term to get the next term. So from here, minus 8 will give me the next term will be 60, and then minus 8 will give me 52, and so on, right? We You can see here that each time in these two examples 1 and 2, we have to add or subtract a common number to get the successive terms. So we can say here, yeah, we can say such such sequence of pattern of numbers in which a constant term, or you can say the other sense, a common difference is same, meaning common difference is same, yeah, of course, or you can say common difference, or the constant term in which a constant term is adding or added or subtracted, right, has to be subtracted with a number to get its next successive number and so on is called a linear sequence. That a linear sequence, you can say, is the one in which you are going to add or subtract a constant number, right, to get the every successive terms. So these are called linear sequence or arithmetic sequence, or arithmetic sequence, because it's related with the plus or minus of the terms. I hope sequence is clear with you. So here for the arithmetic sequence, sometime we need to write the journal term. Yani I'm going to write journal term formula to find any specific term for a linear, other sense arithmetic sequence. So that is, we can write Tn number of terms is equal to a plus n minus 1 times d. This is the formula. Whenever you have confirmed that the given pattern is a linear pattern or linear sequence, then you can use this general formula to find any missing or specifying term. Like here, Tn represent the number of uh, term. Number of term is n. Here, total number right, total number of terms, you can say, yeah. Better, instead of total numbers, you can say uh, is position of term, position of term, that is Tn. Here a is the first term of the pattern, N is the number of terms what we have to find, and D is the common difference, right? So here you can say common difference, that is denoted by D, and it will always be calculated like second term minus first term, or you can write it as third term minus second term, or you can write fifth term minus fourth term. So it means common difference always can be calculated by subtracting the current term with the very previous term. So you can use any one of these to find the common difference. Here this or this is, it will remain same throughout the linear sequence. Common difference will remain same as we did here in the example 1 and 2. I hope it is very much clear. So next step is what to do when the sequence is not linear. Here it was a linear sequence, so that's arithmetic sequence. If it is not linear or arithmetic, what to do? For so we can say for a non-linear sequence, is one in which that we don't have a common difference. A non-linear sequence uh, for which we do not have a common difference, right? Common difference between the terms, and nothing seem to be any adding or subtracting within the terms to get the successive terms. So such sequence is called nonlinear terms. For example, mm, nonlinear term is also non-linear sequence. For nonlinear sequence, you can say we have generally a geometric sequence. You can say, yeah, geometric sequence is one which involves, you can say, yeah, multiplication or, yeah, or dividing by a common ratio. And so far, first we did the linear sequence, that was arithmetic sequence, and in that only addition and subtraction of basic operators can be used. But other two mathematical operators, multiply and divide, can be used for the sequence that is called geometric sequence. Here we can give the example of the geometric sequence to make it more clear. Mm, like we can think on it. Yeah, we can say in the first example, this is example of geometric sequence, right? Yani 3, 6, 12, 24, this and this. right? So here you can see, if you can get the first, see is there anything constant going to be add or subtract to make a common difference. You can see here it is difference is plus 3, here is plus 6, here is plus 12, and so on. There's nothing seem to be common here. But other senses, if we can multiply the first term is 3 with 2 to get 6, and then multiply the 6 with 2 to get 12, multiply this with 2 to get 24, and next will be 24 times 2 will be 48, and 48 times 2 will be 96. So this is a pattern that can only be obtained by multiplying each term with the 2 to get the successive terms. So here you can't plus or minus to get the sequence. So that sequence is called geometric sequence or geometric progressions. And here a is the first term is 3, and you know what the common ratio here r will be the ratio, but above there was a common difference, right? Mm, okay, take the second example. One more example. Here suppose we have uh, say 1200, uh, not 1200, 1600, then 800, 400, this and this. Here you can see what to do, how this pattern we can get it. Like if you can make the difference of this, it is 800 minus, and then it's minus 400. No, it's not a pattern we can have. So betterly difference AP sequence is again not applicable here. But if you divide this with what, divide by 2 divided by 2. So 1600 can be divided by 2 to get 800, and 800 divided by 2, 400, and 400 divided by 2 to get 200, 200 divided by 2 to get 100, and so on. This is a pattern. Here you can see again plus and minus arithmetic operators are not going to be applied here, but geometric progression mean common ratio. You can divide each term with 2 to get the successive progression. So whenever we have such sequence, you can see, let me change the color, like yeah, you can see such sequence in which the successive term can be obtained by multiplying or dividing the current term with a common ratio. Is called geometric sequence. Okay, here multiplied or divide with a combination as the example says. So here the general formula, general term of a geometric sequence can be represented as we can say general term. Yeah, I'm going to write Tn as here Tn was the position of term, so here the same, the position of term is equal to a r raised to power n minus 1, and this is the general pattern. See here, this is the position of term, position of term, this is the first term as even in the arithmetic progression. Here is r, then is the common ratio, and n number of term. Common ratio is divided by r, and it will be the second term divided by first term, or it can be the third term divided by second term. It will remain same, right? Because the common ratio throughout the pattern. So here we have these rules to justify the nth term as we did in the uh, same in the arithmetic progression. So this is a difference in geometric progression. A constant number is going to multiply or divide, while in the arithmetic progression it's an only addition and subtraction of the common difference. Now let's do some examples to practice more on these, and say we have to do some questions. Okay, okay, guys. Now the practice questions based on the discussion we made. That is number one. Find the next three terms in the following sequences. Let's say sequences number one is like this. This is 5, 7, 9, 11, and 13. And also we can add write the formula to find the nth term of the sequences. Okay, we have to write the formula as well. This is a question, and we have to write the next three terms. Okay, let's start. Here you can see first starting, always say start from the common arithmetic sequence, and if it's not, then geometric sequence, and then sometime we have a a specific pattern followed by the consecutive sequence. Mostly we have to check these two rules. So here the first term is what, 5, and if you add 2 in it to get 7, then add 2 to 9, 2 to 9, and 2 to 13. Yeah, very much clear. This is the arithmetic sequence. So next term will be 15, 15, then 17, then 19, and so on, right? Next term will be like this. So arithmetic sequence, we have Tn, the nth term formula. Nth term will be our position of terms. We can say a plus n minus 1 into d, as we wrote it above. Here you can see, yeah, this one, position of term, any, or we can say the nth term of sequence. We call even this same here, nth term of the sequence. Okay, here because we have to define the formula, so here what is a is 5, so Tn will remain n. A is 5 plus n minus 1, and d is, what was d, the common difference 2, so 2. We can simplify 5 plus 2n minus 2, so 2n plus 3 is the nth term formula, which help us to find any specific term. For example, if we want to find, how many terms again? 1, 2, 3, 4, 5, 6 term. So I will replace n with 6. So let's see, t6 will be 2 times 6 plus 3, 12 plus 6, 15. And in the above, yeah, it is 15. We know this is 15. It was here 15 term. So any number of term, if you want to calculate, do replace n with that. You can define the number of term. So if you want to find the hundredth term of this pattern, so instead of keep writing 2 plus 2 plus 2 plus 2 and so on, I will just use this formula and the term formula here I have derived, and then replacing n with 100 to get that answer, right? I hope it is very much clear. Okay, take another example. Another example of this, you can say uh, B part 3, 9, 27, 81, 1, 2, 3. You have to find the missing and then a formula. First, check what kind of sequence is this. Okay, here you can see the common difference is applicable. It is plus 6 and then it will be 18. No, it's not possible. So see here, if the first term is yes is 3, so if you multiply this with 3, I get 99, and then multiply by 3 to 27, multiply by 3 is 81, multiply by 3 is 243, right? And multiply by 3, I will get 9 and 12, 6, 7, 29, and then multiply by 3, 3 now 27, 6, and 8, and 21, and 23, and this is, you know, and this way the we after each term will multiply with 3 to get the successive term. So this is the pattern related with the geometric progression. It's not arithmetic, so we will use this formula here and the term formula to generalize the specific rule. So Tn will be, let me change the color, yeah, Tn will be ar raised to power n minus 1. Here you can see r is a common ratio and Tn is n, a is 3, and r is what, second term divided by third term, or third term divided by second term. It will remain same throughout, right? The pattern is 3, so 3 raised to power n minus 1, so it's 1, so I can write Tn is equal to, by using indices rule, 3 power n is the rule. So this is the general formula. Here I want to check if, say, I have the last term 2, 3, 8, 7. Which one is 1, 2, 3, 4, 5, 6, 7? So if you replace n with 7, so T7 will be 3 power 7. That is 3 into 3 into 3 into 3. 7 times it will multiply itself. So 3, 3 is a 9, 3 is a 27, 3 is a 81. 3, 3 is a 9, 3 is a 27. So 81 multiplied by 27. 7 on the 7, 7 is a 56. You can do it without even calculator. 2 on the 2, 2 is a 16. So 7, 8, 1 and 2. Sorry, it is 2, 1, 8, 7. Right? You can check it by multiplying 729 with 3. 3 9 is 21. 6 and 2, 8, and 3 7 21. Yeah, 2187 is the true answer. Yes, I hope it is very much clear. So this is how we can generate the formula. So after having this specific formula, you have generated for this given sequence, you can replace n with any terms. If they ask you to find the hundredth term, so do replace n with 100 and use the calculator, or you keep multiplying to get the specific answer, right? I hope it's clear. Let's do a few more questions. to concrete the concept. Yeah, I'm going to erase this. Yeah, this is the rough work we did. Okay, we have done C part. C part, yeah, you can think on 0 0.5, say 2, 3.5, 5, 6.5, this and this. We have to give this term and then the pattern. Here you can see the first term is what? 0 0.5, that means 1 by 2 and then 2. Okay, if I can write it as by removing decimal 1 by 2, then 2, then 35 by 2, no, 35 by 10, that is 7 by 2 is 5, and 13 by 2, so on, so on. It means one number is in integer, one number is in fraction. So uh, from here you can see, if you can multiply the first term with 2, or divided by what? No, common difference, say d is same, second term minus first term, or the third term minus second term, it will be 3 by 2, it will be 3 by 2. Common difference is same. Yeah, it means 3 by 2, you have to add 3 by 2 each time to get the next successive term. Like, see, check more, this term minus this term, common difference. If 5 minus 7 by 2, again it will be 10 minus 7, 3 by 2. Yeah, I just took the LCM and simplified to get the answer same. So it means common difference remains same throughout. So by adding 3 by 2 with the very first term to get the next term, and then keep adding 3 by 2 in the current term to get the next successive term, we have a pattern that represent the linear sequence or arithmetic sequence. So next term will be getting 13 by 2 plus 3 by 2, 16 by 2 will give me 8. So here it will be 8, and then 8 plus 3 by 2, 16 plus 19 by 2, I can write 19 by 2, right? Or it can be written as in decimal, 2 9 the 18 and yeah, 0.5, 9.5 here. So finally I will write my answer in the original form: 0 0.5, 2, 3.5, 5, 6.5, then 8, then 9.5. This is the pattern. I hope everyone get it. Okay, the general term now, as it is very much clear, this is an arithmetic progression. So t and nth term will be a is 0 0.5 or 1 by 2 plus n and minus 1 into 1. 3 by 2 means 1.5, right? This is same as 1.5. So 0 0.5 plus 1.5 and minus 1.5, 1.5 and minus 1 is the nth term formula to justify this given example. I hope it is very much clear. Now you can replace n with the number of terms you want to find, and easily you can find it. I hope this is clear, guys. This is enough for the the sequence to be discussed here only with definition. This is the definition. A sequence, let me get a quick recap. A sequence is a set of numbers, pattern that follows a particular order. Number in sequence is called terms. Terms follows each other in sequence are called consecutive terms. So here are the examples: common difference, constant number going to be added, and the next example subtracted. This is a linear sequence. and non-linear mean is not going to be added or subtracted. And nth term formula arithmetic progression or arithmetic sequence is this, and this one is the formula where a is the what first term, tn is the nth term or position of term. For the non-linear sequence in which you don't have a common difference between the terms, so that is called geometric sequence. And then before it was arithmetic sequence, yeah. And geometric sequence, you here multiply or divide with a common ratio. A general formula is here, and then we did few practice question. So good luck, guys. I hope you understand it, and see you for the next video. And in that I will define you how to, I will make the specific formula and for the term which is not linear, not geometric, right? In the first difference is not same. Good luck. Bye.